The most important math problem most people will ever encounter: what does the result of a test mean? The important thing to remember is that you only see the test results. And so the important question is, if the test shows a condition is present, how confident are we that the condition is in fact present? Now, we'll need to develop some language for this. So suppose we have a test for a condition: diabetes, drug abuse, tendency towards becoming a generous supporter on Patreon. The test will either indicate the condition is present, we say the test result is positive, or the test will indicate the condition is absent, we say the test result is negative. Meanwhile, the condition might actually be present or might actually be absent. A true result is when the test result and the reality match. The condition is present and the test result is positive. This is a true positive. Or the condition is absent and the test result is negative. This is a true negative. But it's possible that the test result is wrong. A false result is when the test result and the reality differ. For example, the condition is present, but the test result is negative. This is a false negative. Or the condition is absent, but the test result is positive. This is a false positive. Every test has two quantities of interest. The sensitivity of a test is the fraction, typically expressed as a percentage, but really a probability, that the test will detect the presence of a condition when the condition is in fact present. In other words, it's the probability a test returns a positive result when it should. For example, a home test for COVID, maybe it's 99% sensitive. And so if 100 people with COVID take the test should return positive, and it will do so 99% of the time. And so 99 of the 100 will test positive for COVID. And these are the true positives. They are positive test results that match the reality of having the condition. And notice there is one person who did not test positive. This is a false negative. The test result is negative, but it doesn't match the reality. The specificity of a test is the fraction, again percentage, but it's really a probability, that the test will not detect the condition when the condition is not in fact present. In other words, it's the probability the test returns a negative result when it should. For example, a home test for COVID is 95% specific, so if 100 people with COVID take the test, the specificity tells us nothing about what happens. Specificity only applies to people without the condition. So if 100 people without COVID take the test should return negative, and it will do so 95% of the time. So 95 of the 100 will test negative for COVID. And again, these are the true negatives. They are negative test results that match the reality of not having the condition. And notice there are 5 people who didn't test negative. These are the false positives. The test result is going to be positive, but it doesn't match reality. Suppose we have a test with a high specificity and a high sensitivity. Does this mean the test result is reliable? In other words, a person who tests positive is likely to have the condition, and a person who tests negative is likely to not have the condition. So, if D is the event that a person has a condition, and plus or minus is the event that the person tests positive or negative, then the specificity is the probability of a negative result given that a person doesn't have the condition, and the sensitivity is the probability of a positive result given that a person does. But in both cases, we know whether or not the person has the condition. But what we actually want is the probability a person with a positive result has the condition. And we might also want to know the probability that a person with a negative test result does not have the condition. So remember, there's no simple relationship between the probability of A given B and the probability of B given A. So even if our sensitivity and specificity are high, this does not mean that the probabilities when we switch the events is also high. And in fact, they could be very low. In order to answer this, we need one more piece of information, the prevalence. We'll take a look at that next.